Hello and welcome to the next part of this tutorial series on how to create an application that runs on DirectX 12. Since the last video, I've created a GitHub repo. This includes currently every change made to the application up and including the fourth episode. So yeah, if you need to follow along or don't want to code yourself, feel free to pull the code. I'll try to commit in between episodes as well, so that whenever you start an episode, you should be able to pull the appropriate commit. Yeah. So that's the general plan. In terms of how to keep up to speed. In the end, this will contain the full application, which you can use for whatever you want. Feel free to comment, like, or subscribe, or even support the channel. Link is in the description and available on the channel itself. Okay. So last episode, especially the fourth episode, we got set up in terms of the DXGI factory, the DXGI adapter, and we also created an actual virtual device in DirectX 11 terms. We created this structure here, which is basically just a wrapper that on init creates a appropriate device. So next step will be to do further initialization, but before we do that, we would like to enable some DirectX debugging. We will create a debugging folder here where we will create a DirectX 11 debugger. We will also create a DXGI debugger, but we will start with the DirectX D12 debug. And we will create a wrapper for that, as well as all of the other API related elements. And let's do the engine here. Whoops. Let me just check that I'm recording. Yeah, I am. Okay. And we will, of course, create the same namespace here. As per usual, we will include RWRL and create a COM pointer to the interface, the debugger interface. we would like a static debugger. We only need one, and that means that we will have a default constructor, and we will also have a way of getting a reference to the debugger, which will be static debug, and will get us a reference. Let's see. We could probably do it inline since it's going to return a static instance of this. There we go. Since we create a static variable, we need to instantiate it during uh, I think it's instantiation time it's called. Um, and that will be a memory allocation of this static interface. Let's see, D12 debug. There we go. We instantiate that, or rather allocate memory for it. Enable to in order to enable the debug layer, DirectX12, we need to call this function on the D12 debug interface. Which is given by the example here. Let's see. We would like to be able to actually enable our what do you call it, debug interface. Which we will do. We will create a public method for that, where we simply will, as you can see here, we need to store a debug interface inside our debug controller, which is our debug singleton so basically this wrapper here can store our what do you call it, our interface itself. So we will make sure that we actually do not have a pointer already, meaning that if we already did this, this function shouldn't do anything. We created our evaluation macro earlier. where we evaluate an edge result, and that is because this returns nothing, but this seems to be returning an edge result. Okay, let's d3d get debug interface, and we will do our macro here, and we will get the address of our thing here, and we will print out an error in case this doesn't work. We will of course call the get interface whenever we call enable, and then we would know that the pointer is set, and then we can enable the debug layer on this, and we can also, yeah, we could do an enabled function, but I don't think that we will do that. So this is basically the DirectX debug layer. And let's do enable that. Let's see. The debug layer here. Let's do that. Get did we do no enable, and that should enable our debug layer. Right now nothing is problematic, so therefore we won't get any messages. This could be disabled. Okay. This could be disabled during non-debug builds. You could also say that, let's see the factory here. Hello, welcome. The factory here itself, you could do separate versions for different builds. Should be coupled with the use of the should be coupled with the use of the debug layer. I can't move the live streams to the videos, so they will be in the live stream archive. But they will be there automatically. And so far we have built a debug interface like this, and I've also advertised the GitHub repo where you can download the code. Well, I can't do that in terms of backwards compatibility, but you can sift through different commits. I think so. Yeah, up until episode 4, everything will be the same commit. I think if you set it back to the old commits here, yeah, you can browse the repository before the commits, so you can actually look up the code. Yeah. I both linked the repo in the YouTube description, and also I linked the uh, YouTube on the repo, so everything is coupled. Yeah, but so far we've done the debug layer. It's basically a wrapper around the ID 3D ID D3D12 debug interface. As with all of the other components, I've done a static, or rather a singleton pattern where we only make one debug layer, which also means that nothing beside the runtime allocation controls the allocation of this class, and it's globally available since it's getting pre-allocated at runtime start uh, boot time, or what do you call it, when the runtime starts the application. So, and we've basically uh, set it to enable this debug layer no matter what happens. Next, we will create a likewise debug layer for our DXGI components. The nice thing about these different debug components is that the D12 debug component will give you runtime errors and um, error warnings and so forth in this actual console here. Let me see, can I increase the size of the output so that you might end up seeing it better? Can I do that? View, maybe. Increase text size for the output Visual Studio. Okay, tools, options, fonts and colors. Let's try increasing that a bit. Whoops. That's not what we wanted. Oh, the text editor. Whoops. It was size 10. Well, we select the output window and we increase this to 14. This should be more readable. No, it didn't work on the debug window. I tried that, so thanks, but I needed to do something else. It works during the text thing here, but not down here. This should be more readable if you have problems reading the output of this part. Maybe I should just increase the size even more, since it doesn't bother me. No, it works fine this way. Let's see. Okay, it would like for this to be exported. We can of course do that. We will do the DXGI debug component as well, because as I've started to ramble on about, the 12 debug layer will give live information during the application. It will, for instance, tell you when your buffers aren't the right size and when you're trying to do something that you can't using the DirectX12 API. The DXGI layer allows you to debug whether you have handled your resources in the API correctly. You can do a pretty nice function call with this debug layer that really makes you certain that you handle your well, I disagree. I'm gonna do the debugging because that's a part of actually learning how to use DirectX 12 and any other advanced um, um, graphics programming API. So yeah, we need to do that because otherwise we can't figure out what's going on in our application and where we might be going wrong. So we will implement uh, let's see. Um, a COM pointer as well to hold this interface. Debug. And as far as I remember, we can use the base one. We will do this static singleton stuff again for this class here. And we will, of course, create a static instance of this. We will also create a default constructor. And we will do this inline since it's not doing anything in particular anyway. All right. And we will, of course, instantiate that. M instance here. and we will implement the, oh, we already did that. We would also like an enable function here for this. And let's look up how we will use this enable it. Let's see, methods, report live objects is the method that I was talking about earlier. The interface is obtained by calling this. So let's do the exact same thing as we did for our other wrapper here. We will do a private function where we will get interface, and this will be exactly the same. If the current com pointer doesn't reference anything, we can simply create or get the debug interface here. The first one, let's see, what do we have of different possibilities? We have the, what's the difference? Okay, we can do some thread tracking. Well, we're not going to use that. And we will get the address of our com pointer here, and error creating the DXGI debug interface. And get interface will be our method. And we would also like to be able to not only enable this, but we would also like to be able to get our live objects, which means that we can debug whether we have our object lifetimes correctly handled. If we released our resources, we simply call report live objects, and we need to look up this method. So we can look for specific objects. We would like to get information about all objects. We can also specify some flags. We would like details about the object lifetime. And we would also like to ignore anything that's not referenced. Because if objects reference each other but not by but doesn't get referenced by the application, we don't want that. Why does it bug? Okay, maybe I need to cast this as that. Let's see. Well, that was it. The combination of the flags. Because as I've mentioned, the DXGI debug layer pertains to different objects and their lifetimes, meaning that are there different resources that have not been deallocated or dereferenced in the internal API reference system. And the DirectX12 debug layer allows you to see different DirectX12 specific information during runtime. So yeah, the DXGI is more something that you use for checking whenever an application closes, for instance. Let me show you if I can show you an example. So now our application here would actually have the opportunity to do some object reporting. We can do some debugging here by maybe we want our application here to do an onDestroy method, which will be called, oh, we already did that. Okay, onDestroy. We would like the DirectX, maybe a DXGI debugger here. Did we specify that it's supposed to? Yeah, it's supposed to get the interface whenever we call this. Wait a minute, like this get, and we would like to report our live objects here. No, not that one. We want the one on the actual object. Did we get live objects? It's called instead. There we go. So whenever we close our application, we get a report on, let's see, did I not include that? Oh, okay, I probably need to include the debug header here. D12 DXGI debug. Where is this declared? Debug DXGI debug.header. And oh, maybe I don't, did I? Let me see. Let's see, do we need to DXGI debug.dll? All right, but thanks for dropping by anyway. Sure thing, man. Let's see. So we need to reference the DLL. Let me see, it can't find the method, so Let's see which static libraries do we need to. Maybe it's the older version. Maybe it's the older version that we're actually referencing. Let's try swapping this. This needs a flex because this might be too old. Yeah. The problem was that this one is probably defined somewhere else, and right now we what do you call it? We use a newer method, and we have included our um, uh, interface there. Let's see. Does it? Okay, this is dependent on the Windows platform, and it wants the DXGI lib, which we already have. So yeah, okay. We simply use this method instead to get our debug interface. Yeah, I would have to find the correct lib file to include it. Yeah, you can try asking in the comments. Otherwise, just tune in during the live stream, and we can do it during Q&As. All right. So let's see. Did we get done during doing our application stuff? Yeah, we do. Thank you. There we go. You may be able to see that our DXGI layer now finds a object that is live whenever this part of the application gets called. This means that there's something that we haven't released. Imagine that you wanted to do several windows or several um, different pipelines or view planes or whatever of DirectX 12 work. Maybe you wanted something to render only a 2D UI to one window, and maybe you wanted a 3D DirectX pipeline on something else. And you closed one of those windows, you would need to make sure that um, you handle resource um, what do you call it? Resource uh, dereferencing as intended. So this message here gets posted whenever we call get live objects. When we close the application, if we don't call that, nothing gets posted. Just a second. So yeah, our application here handles our live objects. We saw that we got a warning in regards to an object that is live when we close our application. We would want the renderer to during our destructor here, check if the device that we store and that is supposed to go out of scope together with this um, API, if it's initialized and thereby have a valid pointer underneath it, we simply call the reset function of the com pointer. The com pointer reset function calls an internal release on um, the underlying pointer. So the DirectX API or the DXGI API for that matter would get a call to release the resource. These resources go out of scope whenever we're done initializing, so we actually don't need to release these components since it's done automatically for us. We reference the adapter in our device down here, which means that internally in the API, DirectX knows that a device points to a DXGI adapter. That was also the flag that we saw in the debug setup here. Let's see, can I find it? Here, we decided to ignore the internals, which means that we don't get internal reference counts posted because we don't care. We only want to be responsible for all the external reference counts because we are the ones that manage that. Whatever the system needs to do in terms of cleaning up whenever there are only internal references is none of our concerns. Is not of our concern. Yeah, so this is basically a debug layer. In terms of the YouTube videos, I think I'll stop the recording and upload the video. The stream will, of course, continue. In the next episode here, we will start getting into the more DirectX related stuff in terms of getting up and running. Since we now have our helper systems, we have our device, we have a debugging layer, we can know a bit about what we're doing now. Now we can feel safe exploring how to set up the rest of the DirectX API here. All right, so I'll stop the recording but continue the stream. Feel free to comment, like, or subscribe, or ask questions. Yeah. Also, if you've been subbed for 3 minutes, you can do chat messages. I think I'll change that going on because that might be a long time if you're having the attention span of a modern day human. So let's do 1 minute instead. Yeah, I'll stop the recording and upload the next video.